Modulus of polystyrene E is equal to 0.2 into 10 power 6 and temperature T is equal to 150 degrees centigrade. Then by temperature change into the Kelvin by adding 273, then you get the temperature is equal to 423 Kelvin. And density of the polystyrene given that rho is equal to 1.05 gram per centimeter cube. So you know that 1 centimeter is equal to 10 power minus 2 meter. So the density changes into the gram per centimeter cube to the gram per meter cube. Then you get density is equal to 1.05 into 10 power 6 gram per meter cube. In the question given that universal gas constant R is equal to 8.3 joule per Kelvin mole and molecular weight of the repeat unit is equal to 104 gram per mole. Then the molecular weight of the entanglement calculated by using formula. Then you know that E is equal to rho into R by rho RT divided by molecular weight of the polymer. So molecular weight of the polymer is equal to rho RT divided by E. Put the value of the rho 1.05 into 10 power 6, R is into 8.3, T is equal to 423 divided by modulus 0.2 into 10 power 6. Then you get after calculation you get the molecular weight of the entanglement of the polymer is equal to 18432.225 gram per mole. And this is the answer. Polymer composite of the epoxy and in question number 14, given that a polymer composite of the epoxy and glass fiber in which the volume of the carbon fiber given that BCF is equal to 50%. So the fractional volume of the glass carbon fiber BCF is equal to 0.5. Now calculate the fractional volume of the polyester resin. VM is equal to 1 minus 0.5 is equal to 0.5. Then given that modulus of the epoxy resin EM is equal to 3.5 gigapascal and modulus of the carbon fiber ECF is equal to 350 gigapascal. Now modulus of polymer composite EC is equal to modulus of carbon fiber into volume fraction of carbon fiber plus modulus of the polymer matrix into volume fraction of the polymer matrix. Now taking the ratio of the modulus of the carbon fiber to the modulus of the polymer matrix is equal to ECF divided by EM into BCF plus EM upon EM into BM. Then now ratio of the modulus of the polymer composite to the polymer matrix is equal to BCF 350 divided by 3.5 into 0.5 plus 0.5. So the ratio of the polymer composite to the ratio of the modulus of the polymer composite to the modulus of polymer matrix is equal to 50.5. After solving it, you get EC upon EM is equal to 50.5. A single screw extruder in which the rotational speed of the screw N is equal to 2 rps revolution per second and screw diameter D is equal to 5 cm and channel depth H is equal to 0.4 cm and distance between the flight, that means channel width is equal to 1 cm and helix angle is equal to theta is equal to 20 degree. Now you know the volumetric flow in extruder is equal to flow in extruder is equal to the volumetric flow due to the drag flow plus volumetric discharge flow due to the pressure. But in question given that open flow, that means delta P is equal to 0, so the discharge due to the pressure goes to 0. Then the total volumetric flow QT is equal to only due to the drag flow. Q is equal to drag. So the volumetric flow of the extruder is equal to 1/2 pi into W into H into d n cos theta. Then the volumetric flow of the extruder is equal to 3.14 into W given that 1, H given that 0.4, D given that 5, N given that 2, and cos 20. After calculation you get volumetric flow is equal to 5.9 centimeter cube per second. That molecular weight of the polystyrene amount 250 into 10 power 3 gram per mole at the viscosity neta 1 is equal to 8 into 10 power 3 Pascal per second, and molecular weight of the polystyrene M2 800 into 10 power 3 at viscosity neta 2. Then given that a critical molecular weight of the polystyrene MC is equal to 35 into 10 power 3 gram per mole, you know that the relationship between molecular weight of the polymer and viscosity two term. If the molecular weight of the polymer sample is less than molecular weight of the critical, then the neta is equal to KL into m के power 1. But in case of the molecular weight of the polymer is the greater than critical molecular weight of the polymer, so the neta is equal to KH into molecular weight के power 3.4. जो कि in given question both the molecular weight of the sample M1 and M2 both are the greater than critical molecular weight of the polymer, so use this formula. Now taking neta 1 is equal to KH into M1 के power 3.4 and neta 2 is equal to KH into M2 के power 3.4. Now neta 1 upon neta 2 is equal to M2 upon M1 के power 3.4, where KH and KL are the constant, so these are the cancel out. Okay. Now you get neta 2 is equal to neta T is equal to neta 1 into M2 upon M1 power 3.4. Now neta 2 is equal to 8 into 10 power 3 into 500 into 10 power 3 divided by 250 into 10 power 3 power 3.4. Then after calculation this you get viscosity of the polymer neta 2 is equal to 84.44 into 10 power 3 Pascal second. For the sample 1 I specimen with the percentage crystallinity Xc1 is equal to 50% now. So the fractional degree of crystallinity Xc1 is equal to 0.5 and density of the sample I specimen rho 1 is equal to 2.144 gram per centimeter cube. For the specimen 2 a sample 2 the percentage crystallinity Xc2 is equal to 75%. So let the fraction the degree of crystallinity in the fraction Xt2 is equal to 75. Now and given that density of the sample 2 rho 2 is equal to 2.215 gram per centimeter cube. Let the density of the amorphous phase is equal to rho A and density of the 100% crystalline phase is rho C. Now the relationship between the density and crystalline given by the 1 upon rho is equal to 1 upon the density of the polymeric sample divided by the degree of crystallinity, the fractional degree of crystallinity divided by density of the crystalline phase plus 1 minus Xc divided by density of amorphous phase. Remember this formula. So for the sample 1 upon 2.144 is equal to 0.5 divided by rho C plus 1 minus 0.5 divided by rho A, equation 1. And for sample 2 1 upon and for sample 2 1 upon density of the sample 2 2.215 is equal to Xc 75 divided by rho C plus 1 minus 0.75 divided by rho A, equation 2. After solving equation 1 and 2 by elimination of the rho A, rho C and rho C density of the crystallinity, you get the density of the amorphous phase is equal to 2.0164 gram per centimeter cube. Modulus of the spring E is equal to 10 power 10 Pascal and viscosity of the dashpot neta is equal to 10 power 12 Pascal second. Both the spring and the dashpot are connected in the series. Then this is a spring and this is a dashpot. Its modulus is equal to E and viscosity of the dashpot is equal to neta. Initially E applied sigma, stress sigma. At time t is equal to 0, sigma is equal to 0, and at time is equal to 50 seconds, sigma is equal to sigma naught. At fixed strain, gamma naught is equal to 1%. That means gamma naught is equal to 10 power minus 2. Now using the Maxwell model's equation, gamma is equal to sigma into 1 upon modulus of the spring plus T divided by viscosity of the dashpot. So gamma naught given that 10 power minus 2, sigma you should be calculated, neta E given that 10 power 10 plus T is equal to 50 second and viscosity given that 10 power 12. After calculation you get sigma is equal to 1 upon 1/5 into 10 to the power 8, then 0.666 into 10 to the power 8. So sigma is equal to sigma naught is equal to 6.67 into 10 to the power 7 Pascal. So answer is 6.67. So answer is sigma naught is equal to 6.67 into 10 power 7 Pascal. This is answer. Concentration of the initiator increases by the 4 times and concentration of the monomer increases by the 2 times of initial. So for the free radical polymerization, you know that if the termination done by coupling, then the number of the degree of polymerization is equal to 2 times of kinetic chain length. If the termination done by disproportion, then the number of the degree of polymerization is equal to V. Here V is equal to kinetic chain length and V is equal to kinetic chain length defined by the rate constant of the polymerization into concentration of monomer divided by root of the F into KD into KT into concentration of initiator. Here F is equal to initiator efficiency, KD is equal to rate of initiation, KT is equal to rate constant of the termination, I is equal to concentration of initiator is equal to rate of polymerization divided by rate of initiator is equal to rate of polymerization divided by rate of termination. This equation, remember, for the kinetic chain length. This is the kinetic chain length. Now, so the kinetic chain length V is proportional to the concentration of monomer to square root of concentration of initiator. So ratio of the concentration of kinetic chain length at V2 divided by V1 is equal to concentration of monomer M2 divided by M1 into square root of I1 upon I2. So in question, the concentration of the monomer increases by 2 times of the initial M1 upon M2 and initiator is increases by 4 times of initial So you take V2 upon V1 is equal to 2 divided by 2 is equal to 1. That means V2 is equal to V1. So no change in kinetic chain length. Kinetic chain length. So the number average. So the number average of degree of polymerization is not changed. Then x1 is equal to xn2 is equal to 100. Question, because xn given that in question 100. D2 D spacing मतलब distance between the two molecules, let molecules 1 molecules 2 and applied stress sigma. Then this D spacing is measured by XRD before applied stress and after applied stress. But when applied the stress, the polymeric sample, the D spacing between the molecules and sigma given that 160 megapascal. Now strain produced in the polymeric matrix is equal to change in D spacing distance divided by initial D spacing distance. That means delta D divided by D1 is equal to D2 minus D1 divided by D1. By using Bragg's equation, you know that the relations between the incident wavelength of the X-ray and d spacing given by n into lambda is equal to 2d sin theta, where d is equal to d spacing, theta is equal to angle of deflection, lambda is equal to wavelength of the X-ray. So now here the strain produced in the polymeric sample is given by d2 minus d1 divided by d1. Then using this Bragg equation, d2 is equal to n lambda 1 divided by sin theta 2 minus n lambda 1 divided by sin theta 2 divided by n lambda 1 divided by sin theta 1. Okay, the wavelength of the X-ray remains same, that means lambda 1 is equal to lambda 2, and also the peak of the d spacing is remains same, and n1 is equal to n2. So the strain produced in the polymeric sample is equal to 1 upon sin theta 2 minus 1 upon sin theta 1 into sin theta 1. Then put all the value, you get strain is equal to 1 upon sin 375 into 1 upon sin 3745 minus 1 upon sin 375. Then you get strain. After calculation of this, you get strain produced in the polymeric sample is equal to 1.138 into 10 power minus 3. This is answer.